AP Stats. We are AP Stats. All right, guys, we're gonna have our review session. We're just gonna get after it. We have our cup today. You know, got the tickets. Gucci. All right, Ryan's gonna give us a shot. Oh man.
Oh man, it's okay. Get it next time.
It's okay.
Wait, what else does he do? Oh wait, Jaden, do you? Okay, Charles.
All right, Charles. Come on, Charles. All right, let's see. Do we have anybody here? Let's see. Who's on?
Oh, I see you, Eric.
Yeah, Eric.
I see you, Eric. Oh, Lindsay's here too.
All right, Gucci. What else is
What y'all?
We were getting your podcast started.
Yeah.
We took and missed the shot.
Stats. We're AP Stats.
You all have already introed it.
Yeah.
What's up, AP Stats? How we doing today? It is chapter 11. This is the last podcast review. I hope you're having a great day. We've got some friends in the house. Well, some friends. Get out of there, Ryan. There we are. There. Nope.
I'm your friend.
We're gonna get it going today, and hope you're pumped, jazzed, Jimmy jacked.
Bro, is this what your podcast?
This is our podcast. This is our podcast. Let's go. All right. So as we get started, concept list is what's behind me. I, with my friendsies, have asked them to throw out some questions over the concept list, and we'll start there. So grab your stuff and let's have a statistics party.
Yes.
Let's go. Let's do it. All right, questions. Let's go.
Okay, can you say the null hypothesis for each of the tests that we have to do?
Yes. Okay. So chi-squared golf, the null, and the alternative. Okay. All right. The null states. Let's see if this will work. All right. The null states that the claim is true. Okay? The claim is true. Now, what's the claim? Whatever we're talking about in the context of the problem, right? Yeah. But the claim is true. Therefore, the alternative is the claim is not true. Again, I'm not putting in context here, but that's the idea is that there will be context on that. Okay? All right, the second one, chi-squared association. Okay? All right, yes, it's on the podcast. All right.
You wrote a bad word.
I did.
I'm telling Robbie.
Yes, show it. See what he does. No, I'm sorry. No, I'm sorry. Do not share this. Do not share this. No. All right, so chi-squared association is, the first thing is that there is no association, right?
Yes.
There's no association. We're out of room. And then the alternative is there is no association.
Can you also go over the area?
They're both there's no S?
Oh, I'm sorry. There is. I got so excited about writing
There
that.
is and.
There is an association. Okay. All right. So the null is there's no association, and the alternative is there is an association. Thank you very much.
Can you
All right.
go over how many samples and variables?
Right.
each one has?
Yeah, we'll do that for each of these. Is that cool?
Yeah.
So let's do chi-squared homogeneity. Geneity, whatever. The null versus the alternative. What's the null?
There is no difference.
There is no difference. And the alternative is
There's a difference.
there is a difference.
What's the difference between there's a difference and there's an association?
A great question. There, a lot of times they're the same, right? You could convert one to the next. The big thing is just the amount of samples that you have and how you respond. So remember, association is like independence. Does one thing relate to the other? Remember, association, we're looking at two variables from one
In one sample?
sample. Yeah. So is there an association between the 2 variables. Cool.
And golf is one sample, one variable, right? And then
One sample. Yeah, one sample and 1 variable.
and then the homo one is 2 samples and 2 variables.
2 samples with 1 variable.
So none of these will ever have like 4 variables.
Well, the homogeneity one might have 4 samples. Like you could compare all these different types of gummy bears and then see if there is or is not a difference. But the variable, you're right, you're only comparing 1 variable. The variables are pretty constant. Cool.
Yeah.
All right, are we good on that? All right, so
wait,
that's all that stuff.
Oh, wait, I missed this.
I'm just kind of looking at the concept list first, and then we can go kind of off of some FRQ stuff if we need to. How could the sample size impact the test of chi-squared? How could the sample size impact the test of chi-squared?
Okay. Sample size. Does it matter which chi-squared? I'm responsive.
Let me look at this real quick.
Coach J. Well, that's up to you.
Let me do this. Hold on just a second. There's one question on here I wanted to put on here for the test. Is it frozen behind me? Yeah. All right, let's see. In a Coach J is smaller than a one that we are 8 piece that we are 8 piece that
No, you did not.
you don't ever forget. Yep, yeah, see.
I don't know how I feel about that.
Charles jealous. Laffy Taffy, come on. Hey, I'm sorry, Charles. Please forgive me. Please forgive me. Charles, my apology. My apology there. All right, let me see. All right. Man, did you?
Ryan, did you know Coach J said he's going to get a tattoo
Oh.
if all of us get higher than a 3?
You put this on the podcast right now.
Proof. He said that, and I know he would never break a promise.
All right, so the probability of chi-squared has to always be greater than or equal to? Oh my goodness, yeah, this is crazy. This is crazy. I know y'all are seeing oh my goodness. Y'all are crazy.
This is too much. You should never do a podcast with them in here again.
I know, we are unproductive. I'm actually looking at this real quick.
We're just giving you some music.
Background music.
Wait, it's a real song?
Yeah, I wrote it. All right, so question. The more degrees of freedom a chi-square distribution has, the smaller the mean of the distribution.
Say that again?
The more.
Degrees of freedom a chi-square distribution has, the smaller the mean of the distribution.
Say it one more time.
So talking about,
The higher the degree. Oh yeah, because when we did that little graph, the degrees of freedom was like 1.
yes,
It was really, really small.
Oh, yeah.
y'all follow me on that?
So the higher degree of freedom is what?
Higher degrees of freedom makes it more approximately normal. Got me? Makes it approximately normal. I want to look up this one last thing. And I know you're just looking at me right now saying, Coach, what is this? That really was huge help right there. I would take that, put that down.
Is that one of those 1, 2, 3?
Yeah, it's 1, 2, 3. That's what I was looking at.
I hate those. Coach Jay, you've watched
Looking at this.
lately. I'm happy for you.
What's that?
You've watched this cup.
I actually haven't. I've not watched it all year.
You've not watched it?
The cup.
I am so scared. I'm nervous.
No, he drank from it. I'll drink.
Is this forever? Is this going to be on your website?
Okay, yeah. So, okay.
I'm shouting. You know you're-
All right, hold up. There's another one. All right, so when we talk about, I think there was one that we actually had that I want to go over. Could y'all remind me in y'all's classes about starting off with a quick problem? Does that make sense? And I know y'all can't see me right now. Y'all are just seeing the back of my head. But there's one problem. Remember when I said mu1 equals mu2 equals mu3 equals mu4 is a multiple choice question?
Yeah.
And I think I might have even said something about like it's correct or something.
Yeah, no.
It's actually not correct.
It was P1.
Yeah,
Oh.
P1, P2, P3, P4. Anytime with the null and the alternative with a chi-squared, test of association, independence, or golf, remember that the null and the alternative is simply words, right?
Yeah, that's what
The null would be stating that the distributions for all of those is the same, right? Or we would say the claim is true. So just make sure, just make sure that like it's evenly distributed among all of those, whatever their claim was there.
So this one,
Number one.
number one, can you explain that? Because like,
Is that
why is it a P?
Yeah, it
Isn't that
shouldn't
what you
be. That would be proportions, so that would be thrown out anyway.
Well, that
That's
was
not the
what-
correct
oh.
answer. Let me look at number one again, and I'll get back with you, okay? All right, let me look at number one. Just thinking through the question that I was talking about earlier, where we said that the degrees of freedom of 10 or more is roughly symmetric. Well, it's never roughly symmetric, right? So remember, it's always going to be skewed to the right. Does that make sense?
So it's not roughly symmetric. It's roughly symmetric, but it's not.
What's right?
Coach Jack.
Awesome. Very
How
cool.
was it?
Thank you, Cliff.
Chloe, you just have to read.
Okay.
Chloe just took the test.
Okay. Hey, this is what I wanted to go over, and this is our last thing. Chloe, did you dominate?
The test. We're doing the review podcast.
You're on the podcast right now. They just made fun of me, Chloe. I know that's really surprising.
Yeah, we just introed with all of
All right, I didn't want to go over this part. This is it.
Coach
All right.
Shay, go over more of the null and the difference between null and alternative for each
Yeah.
test. What is
Where
happening?
that just came from?
I am so scared.
Cool.
Coach Shay.
The null and the alternative?
Yeah, for each
Cool.
test.
Gotcha.
That was the confusing part for me.
The null and the alternative?
Yeah, for each test.
So you heard it from Chloe here. Studied the null and the alternative. We just actually went through that. Just like the difference between the two. Yeah, absolutely. So I would say go back and just touch base on that. Good
Okay.
wisdom there. I did want to say, so as degrees of freedom increase, what happens to the graph? It does become more and more normal, right? So a high degrees of freedom compared to a low degrees of freedom. Okay? So as we look at it, what we can say is this, okay? It's not approximately normal. Does that make sense? It just becomes more normal. Okay, so think about this. A low degrees of freedom, where's the mean? Is the mean going to be to the right or to the left?
Further to the right.
Further to the right. So this is mean, and the median would be here, right?
Yeah.
But when it's more normal, does that make sense?
Yeah.
The mean
And the median are closer.
and the median become closer together. So the median would actually increase. The mean would actually decrease. You follow me on that?
Yes.
Okay, cool. Cool. That's like a deeper question, so just heads up. All right, do you see anything else in here that you're like, I need to go over? I have
The
questions on?
conditions that need to be met. So one of the multiple choice questions was, which of the conditions are satisfied? Okay, it was like the conditions for carrying out the chi-squared test in exercise 12 are, which are the two conditions that we know, and then independence.
Yeah, 13.
So
Is that question
are we
13?
Yeah.
I think
So
I
are we
have 13
supposed
on here. Is
to,
that it?
Yeah.
Cool. The conditions for carrying out the chi-squared is in an exercise 12R. Separate random samples from the populations of interest. Yes. Expected counts large enough. Yes, that's greater than or equal to 5.
number 3 is what I was confused about because we don't have to, when we write out for the FRQs, we don't usually have the same dependence, but like in all of our homeworks, it was like.
What was the answer to that?
E.
E? You said 1, 2, and 3?
Yeah.
Samples themselves and the individual observations in each sample are independent. Oh, that's the 10%, isn't it?
Yeah. Well, that's what I meant.
Yeah, here's the deal. I've seen the 10% rule used and then not used. I would say that in any case where you have something that if I have 2 observations, you don't want one thing impacting the other. So I would say this is true. Now, this is relating to that 10% rule. If it's not independent, I just would say the 2 samples are usually different from each other, so you don't really have to show that. But they do need to be independent of each other. So I would say that E was right. I feel like that's unfair a little bit just because it kind of sounds weird. 1 and 2 are the ones that you show on the FRQ, right?
Yeah, so we don't have to show independence. Just 10%.
Correct. It's a good question. Let's go to 1 because I think that one was the one that people were.
Just a quick question. When we do the goodness of fit tests, can we also use like the A and B table to find the expected count?
Say that one more time.
So you know, for like the goodness of fit test, we usually calculate with the
L1, L2.
Yeah. Do we have to? Can we do the same thing in like the A chart thing that we use in the other ones?
I'm not sure. I think you actually have to calculate the expected there.
Okay.
Remember that?
Yeah.
I think the expected, so this is a good example. This is the observed. And so they asked the question of when they took 100 trees and counted the number in each quadrant, they wanted to know whether the trees are randomly distributed, right? Well, if they were randomly distributed, what would be the expected?
If they're not randomly distributed. Oh. Wait, what?
How would I find the expected?
The expected would be.
Yeah, but this is only one.
Expected
table,
would
right?
be.
So this is a goodness of fit, is it not?
You want all of them to be
Wait,
25.
how is it a goodness of fit? Because you said in class today that it would say like the claim is, but randomly
No,
distributed.
you're right. But this is the only. Remember, this is not a like 2x2 matrices. This is just one claim, right?
Okay.
So that's one hint is the fact that we've only got these 4 on the 4 different quadrants. We know that to be true.
The
Right?
null is that they're not randomly distributed, so it would be 25.
Correct. So the 25. So we would say the null is that they are not randomly distributed, right?
Yes.
How is the null that they are not? Why is it not?
Because if they're not randomly distributed, well, this is the observed, but if they're not randomly distributed,
Hold up, let me see.
you're trying to figure out if
Hold
they
up.
are-
Researchers wondered whether the trees in the Georgia are randomly distributed. Yes.
Yeah, because the and 3C
Yeah.
is the correct answer. That they're not randomly distributed.
So we're trying to prove that they are not.
No, we're trying to prove that they are.
But I
So
thought
that's
we-
why the observers are not the same number.
Correct. So the expected would be that they would be in 1, 2, and 3,
And
right?
they're all the same numbers.
And they would be all the same number. So if the sample size was 100, right? Sorry, not 1,000, 100. And we would say 25% would be in each. You follow me? 25% times 100 is 25, right? That would be the expected, right? If they were not randomly distributed, we would just say that they're all equal, right? They were placed there equally. But if they were randomly distributed, we're going to see this provides some evidence, but is it convincing, right? And that's why here it would be observed minus expected, 18 minus 25 squared divided by expected, which was 25. So I was trying to see.
So we put the one
The
that
A.
we wanted to be true to be the alternative.
Correct. The alternative, because you're trying to show that, right? So we're saying that in the beginning, they're not randomly distributed. That's the expected. The fact that they alternative is that they're randomly distributed. So which one would say that they're not randomly distributed?
This is what I was confused about, because I thought it'd be that C. But I don't know why it's D. Well, I would think that, well, the one that we saw on, like, we had this, I think we had this similar example when we did it, like, earlier this week,
Yeah.
and those were not the answer choices. That's why I don't I don't know where we're getting P from.
I don't know either.
I guess it's like the same percentage. You're trying to prove that they all have the same proportion, so they're not randomly distributed.
I'm getting confused on the wording. I think
Yeah.
you are too, Jaden.
Yeah.
I'm getting confused on the wording a little bit on how they're saying it's D. I think they said it on there, but I don't know why that's the case. Let me write out this. Let's go away from the null, the multiple choice. And let's just go to what we would put as the null. Okay. The null it would be what? Well, they're trying to find. Researchers wondered whether the trees in a longleaf pine forest in Georgia are randomly distributed. Okay. So the alternative they're trying to show is that the trees were randomly distributed. That's what we're trying to find, right?
Yeah. Researchers claim it's true.
And so the null is
They were not.
the trees were not, right?
So, when we
Randomly
do
distributed.
goodness of fit, we always say the null is true. So, but in this case, the researchers' claim wouldn't be true if we put that. You know how we
The
say
trees
for the
were not.
null,
That's where
the
I'm
claim is
confused.
true.
And that's where the wording for me is a little bit confusing. Maybe I don't know enough about trees, but the trees were not normally distributed. If they were normally distributed, right? Or they're not, right? We're assuming that they're not.
If they weren't.
If they were not, but then wouldn't we just put 25, 25 into each?
Yeah.
So that's good. That means that we expect that, right?
Makes sense.
So that's good. The trees were not normally distributed, meaning this is true, right?
Yeah.
N1, N2, N3, and N4 would be 25. I would say that it would be C, but I don't like, here's what I don't like, because on the test tomorrow, this is not going to be the right answer, because if they use mu1, mu2, mu3, mu4, that's not, we're not talking about mean, right? We're talking about the sample sizes are equal to each other. Now, I could say, I like saying the trees were not normally distributed, and from quadrants 1 through 4, they would be expected to have 25 in each. And how did we do that? Remember, expected is equal to n times p.
Why wouldn't we say that the claim is true, the claim is not true? Because I understand what the null is that we're talking about, but you say like when we first learned it, it was like the claim, the distributor's claim or researcher's claim is true, but in this case, we're not trying to prove that the researcher's claim is true for the null.
Yeah, that's what I was getting confused.
Because you know, like the researcher's claim is that they're randomly distributed, but that's not what we're trying to prove that they are. But the claim, the null would be the researcher's claim is randomly distributed.
Yeah, I hear what you're saying. I would say the wording again, but if the researchers are the one, they're creating this experiment, right? They're wondering, hey, we think that this is randomly distributed, right? Therefore, we show what is that claim true or not. The opposite of that is if the researcher said, hey, it's randomly distributed, and we say, we don't think it is. And then we go against that. Does that make sense? That would be a little bit different, okay? So I hear what you're saying. Do you hear a little bit of what I'm saying on kind of backwards?
Yeah, I think so.
I think it's,
Will it just be more clear tomorrow?
Should be.
I think I know.
You hear what but being able to also identify, okay, the researchers wondered whether the trees in the pine forest are randomly distributed. They wondered. They're the ones creating it. That's why the alternative is that they think that their trees are randomly distributed. It's different from them saying, we claim that they are, and we say, no, you're not, you're false.
Yeah.
At that point, we would flip-flop the null and the alternative.
Okay.
Okay?
Yeah.
Cool. All right. Another one. Y'all have another one?
Can we go back to the concept, please?
Yeah, absolutely. Okay.
Okay. The degrees of freedom is the same. The only thing different for the degrees of freedom for homogeneity and association is it's rho minus 1 times column.
Rho minus 1 times column. minus 1.
And then goodness
Exclude
of
the
fit.
total one. Exclude totals, right?
Yeah.
Exclude totals.
And goodness of fit is just the regular one.
Yep, this is categories minus 1.
Oh, categories. Oh,
This is for expected.
This is for finding the degrees of freedom. Degrees of freedom.
chi-square and using chi-square CDF or table C.
Say that again.
Number 13.
Okay, so this one would be, and I'm just making one up, okay?
Oh wait, good question.
Yeah.
What was the
Oh, it's rows minus 1.
This one? Row
Yeah,
minus
is
1,
that for
column
both?
minus 1.
Yeah.
okay. All right, got it.
Cool. I'm going to go forward here. I want to show you something. I'm going to totally make this up, okay? So this is
Okay.
totally made up. But let's pretend that this is our problem, number 2. And it's showing they take one random sample, 687. And they wonder, is there an association between the degree held and the opinion about astrology? What type of test is this?
Opinion about astrology. So 2.
Is it?
Good. Chi-squared of association or independence. Okay? Good. What if I said the test statistic was 6.83, okay? 6.83. And let's say that they just want to find out what is the p-value and whether it is statistically or significant or not, right?
Okay.
Now, let's draw the picture real quick. Here we are. We highlight it. This is 6.87 here as our test statistic of chi-squared, okay? And this is our p-value in this spot right here, okay? How do I find my p-value?
You do table C. Well, you can use your calculator and do chi-square test.
You wouldn't be able to do that. You don't have enough data.
Is there
Well,
like a-
let's say you excluded this.
Oh, is it kind of
know?
like, could you do like a, is that what where normal CDF comes in? Where you do
You could do table C, or you could use chi
Oh, yeah.
squared CDF. Good. What's the lower bound?
Negative 999.
like 6.8,
6.87
3, 8, 7.
and 99999, right? What's the degrees of freedom?
So
3 minus 1, 2.
Good. 2. So the degrees of freedom would be 2, and you would say that this is chi-squared 2, or the degrees of freedom of that chi-squared is 2.
Nice.
Then we'll put 2 on this outside. So then you plug that in, and then you could go from there. You could also go to the table C and just put in 2 degrees of freedom, chi-squared of 6.83, and then that would give you what the p-value would be as well.
really quickly, I don't know why this is like taking this on here, but like picking up the samples versus the variable. Like I said, independence, which I know is 1 sample and 2 variables, but I don't know like where.
If I see something that has a chart like this, chi-squared should go off in your head.
Yeah.
Excluding golf, because that would be one claim, right? If it was one row, that would be more golf. One claim, we're comparing it to the expected. When we have something that's like a table, right now I would say, okay, let's pick out some keywords. The General Social Survey asked a random sample about whether astrology is very scientific. Here's a 2-way table accounts for people in the sample who had 3 levels of education. Education, opinion about astrology. Ask a random sample.
Okay.
Now, how
So
could
the
I change
degree-
this into homogeneity?
You would be like, you asked the random samples of adults
Is there a
this year,
difference?
and then next year you asked another.
Is there a difference?
Okay,
in
that would be
adults?
good, but keep everything the same.
Is there a difference in adults' opinion about astrology?
Alan, you know?
I would say Coach Jay was with the GSS and asked 3 random samples of adults their opinion about whether astrology is very scientific, sort of scientific, or not at all scientific. Each of the 3 groups would fall in the different categories. 1 sample would come from associates, 1 from bachelors, and 1 from masters. And we would see, does the sample have a difference between their opinion about astrology. You see the difference?
So then it would be 3 samples and 1 variable?
Correct. It's all dependent upon how I word it.
So is it like when you would do the table, would there only be like 1 row of that? I don't know how. Wait, can you repeat what you said?
Yeah, so I would say that instead of ask a random sample, I asked 3 random samples of adults, each holding a different degree level, with between associates, bachelors, and masters, right? So I asked those 3 groups. I then compared those 3 groups according to their view or opinion on astrology. And I wondered if they were different or not. See how that's different now? Same thing, just a different wording. Okay?
How would the table be set up?
Same way. Same way. So look at this one.
So with like.
Okay. Study. I'm going to do this. Can you read that one? All right. Shopping at a secondhand store becoming more popular. Has even attracted the attention of business schools. Study of customers' attitudes towards secondhand stores interviewed separate random samples of shoppers at 2 secondhand stores of the same chain in different cities. 2-way tables show the breakdown of respondents by gender.
So they're 2 samples. So, but like, you're trying to. Oh, so so
Homogeneity.
because it's 1 variable, their attitude towards second.
Well, it's two variables, right?
Can you have more than 1 variable in homogeneity?
No, it's only going to be 1 variable. So
The variable is the attitude towards second stores. But why is it store A and store B? That's why like it confuses me.
yeah, that is weird. I would say 2 samples are store A and store B. And I would just say it's not necessarily attitude, it's more gender, who shops there. You know what I mean? I could see that because it should be attitude, and I get that. Like, what's their attitude? It goes from there. The table doesn't show that same thing. So I would just say that store A, store B are the 2 samples, and the variable, the variable is the gender.
And categories.
Correct.
They're always going to be categories.
Correct. Cool?
So, okay. So those, like where male and female are, those are always going to be categories.
Yes.
So I guess my question is, how come A and B for store are 2 variables, but associates...
Not 2 variables, 2 samples.
2 samples, but associates, bachelors, and masters are not 3 samples.
Yeah, you got to be careful on the wording, right? Up here it says, a study of customers' attitudes towards secondhand stores interviewed separate random samples of shoppers at 2 secondhand stores. Over here it said, on the second one it said just 1 sample, right?
Okay.
That's the difference. Okay?
Separate random samples.
Does that make sense there? Cool. All right, do you have any other questions at all?
What do you mean by exactly sampling distribution? Know how to find mean, standard deviation?
Where's that one again?
15.
Oh, yeah. Okay. So, yeah. So if I say you have 50 roses, where the average mean, I'm sorry, that's the same one. The average height is 11.5 inches, okay? With a standard deviation of 2.8. Y'all follow me on this?
11.5 inches, 2.8.
You remember this idea of mu of x bar equals mu?
Yes.
Okay? And this idea of s, or sigma, of x bar equals s of x over square root of n. That's what we're talking about.
Oh.
And then I might have to say, like, what is the probability that when choosing those 50 roses, that the inches would be greater than 13? Well, that's a normal distribution, right? You have 13 here, or greater than 13, right? The mean of this would be mu, which would be 11.5. And the standard deviation would be 2.8 over square root of 50.
So
And then once I get that, I would do normal CDF, lower to upper, mean, and standard deviation.
what does that have to do with chi-squared?
That's a one review problem on there. That's question 11.
Okay.
So there's 11 questions on there. It's one question. So,
All right.
yeah. I know we haven't gone through any FRQs, but I know we've gone through a lot. Are there any other things that you think of? Cool. Cool. I think the big thing, y'all, is FRQs. It's going to be the same thing. I mean, you know what to expect on the FRQ side. We did one today in class, knowing the difference between the three. You're going to have one, I think it's one association, one homogeneity.
Okay.
I'm telling you now. So know the 4 steps. There's additional questions there's one additional question after each one. One is really hard. One we've already gone over. The ones you're going to have to think about, you're going to have to really put a lot of thought into it. But that's the last question on the test, I believe. All right, do y'all want to say anything as we head out?
Jaden got into Spelman.
I did.
Hey, congratulations, Jaden.
Thank you.
Even when you're
We are. Oh my gosh, I was about to say something.
what?
You can't see
The lighting in here is not brown.
It is not. It is literally a shadow.
This is live on YouTube.
Oh my god.
Oh my word!
It
Oh
is
my word!
not Audrey. It's not that.
Have a great day, y'all. Be blessed.
Test. Everybody's gonna do great.
All right, very good. Have a good day.
Coach Shay, did you talk to Coach Shay?